Today we will discuss Chapter 12, Atoms and the Periodic Table. Something to consider. If in some cataclysm all of scientific knowledge were to be destroyed, and only one sentence passed on to the next generations of creatures, what statement would contain the most information? I believe it is the atomic hypothesis that all things are made of atoms, little particles that move around in perpetual motion, attracting each other when they are a little distance apart, but repelling each other upon being squeezed into one another. In that one sentence, there is an enormous amount of information about the world. Richard Feynman, Nobel Prize winning physicist. Atoms are the smallest building blocks of matter. They can contain a nucleus and an electron cloud. If a carbon atom from your skin were the size of this marble, your hand would be 4,000 miles across. Elements contain one or more of the same type of atom. Some examples of elements are hydrogen, oxygen, gold, potassium, and neon. Compounds contain more than one type of atom. An example of an organic compound or a compound with carbon atoms is carbon dioxide. It contains one atom of carbon bonded with two atoms of oxygen. An example of an inorganic compound, a compound without carbon atoms, is water. Water has two atoms of hydrogen and one atom of oxygen. Helium is an element and the second most abundant element in the universe. Helium was discovered by analyzing light from the sun. When cooled to negative 450 degrees Fahrenheit, it becomes a superfluid. Inhaling helium temporarily alters the sound of a person's voice due to oxygen deprivation and momentary asphyxiation. Helium is also known as one of the noble gases. Helium has never reacted with another substance and has never been anything but a pure element. Why is that? It's due to its atomic structure. All atoms contain particles called electrons. Electrons orbit around the nucleus of an atom. The nucleus is made up of protons and neutrons. The nucleus is the positively charged central core of an atom containing most of the mass. Electrons are very, very small subatomic particles with a negative charge. A proton is a subatomic particle located in the nucleus of an atom with a positive charge. A neutron is a subatomic particle located in the nucleus of an atom with a neutral or no charge. Protons have a fundamental charge of plus 1 and a mass of 1.63 times 10 to the negative 24th kilograms. A neutron has no charge and about the same mass of 1.675 times 10 to the negative 24 kilograms. An electron, however, has a negative charge and has a much, much smaller mass of 9.109 times 10 to the negative 31st kilograms. This means that an electron, though much, much smaller than protons and neutrons, carry the same magnitude of charge in the opposite direction as a proton. Why does helium not bond with other elements? It's due to its atomic structure. Electrons reside in different energy levels surrounding the nucleus, or in Earth terms, different altitudes. These altitudes or energy levels are sometimes referred to as shells. Each level needs a certain number of electrons to be full. The innermost level needs 2 to be full. The second level from the inside moving outward needs 8, and so does the third. Once these shells are full, they do not lend themselves to bond with any other element or accept electrons or give up electrons to any other element for the purpose of bonding. This is why helium does not bond with other elements, because all of its shells are full. Atoms normally have an equal number of positive protons and negative electrons, so they are electrically neutral. Electrons can freely be traded between atoms so that when an atom gains or loses an electron, it becomes an ion. Atoms fill their inner lower energy levels as full as possible with their own electrons, then either shed, share, or steal electrons to secure the right number in the outermost level. Helium has never reacted with another substance, has never been anything but a pure element. Why is this possible? Again, helium has exactly the number of electrons it needs to fill its only level. It does not and will not interact with other elements because of this. Helium is the first of the noble gases. Noble gases are elements with full outer shells, so they do not react with other elements under normal conditions. The noble gases are helium, neon, argon, krypton, xenon, and radon. Halogens are some of the most energetic and reactive gases that we know about. All of the halogens form acid when combined with hydrogen, and all are toxic. Examples of halogens are fluorine, chlorine, bromine, iodine, and astatine. Alkali metals only have one electron in their outer shell and are very reactive. Instead of rusting or corroding, they can spontaneously combust in air or water. Examples of these elements are lithium, sodium, potassium, rubidium, cesium, and francium. Alkali metals can combine with halogens to produce potassium chloride. The periodic table of elements is stocked full of information, and there are arrangements of elements in groups or families. For example, in column 1A, the further you travel down that column from hydrogen to francium indicates the level of reaction with air or water. When we read the periodic table, there are two very important pieces of information we can get. The atomic number, which is in the upper right-hand corner, which indicates the number of protons each atom has, and the bottom number, which is the atomic mass, which indicates the mass of an atom expressed in atomic mass units based on the carbon-12 atom. The atomic mass unit also tells us the number of protons and neutrons on that particular element. When you subtract the atomic number from the atomic mass, you get the number of neutrons. Isotopes are atoms that have different mass than is listed on the periodic table due to an equal number of protons and unequal number of neutrons. The equation for the atomic number of neutrons in an atom is given by the number of neutrons equals the atomic mass minus the atomic number. Ions are atoms that have an electrical charge. They have unequal numbers of protons and electrons. A positive ion has more protons than electrons. A negative ion has more electrons than protons. In order to adjust the number of protons and electrons, we simply remove or add electrons from the atom. We never take away protons from an atom. Sometimes atoms can be identified using light. A device known as a spectroscope allows us to use that instrument to separate and spread light into its color component frequencies. It allows the analysis of light emitted by that element to be captured. From that reflection or absorption, we get a dispersion pattern that shows absorption lines at given wavelengths of light. Each element emits a distinctive glow when energized and displays a distinctive spectrum when that spectrum is exposed to some recording medium, such as photographic film or a photographic plate. Then scientists or those using the machine can tell us exactly what elements are in the sample that was exposed to white light. Let's recap the things we need to remember for our exam. Atoms are the smallest fundamental units of matter. Electrons are negatively charged particles residing about the outside of the nucleus of an atom. Ions have different numbers of protons and electrons, and the charge changes. Noble gases are stable elements because their outer shells are filled and do not lend themselves to bond due to electron sharing. Protons are positively charged particles with a charge of +1. Neutrons are neutral particles with no charge. And isotopes have different numbers of neutrons and protons, and they have different atomic masses due to their differences in particle payload.